Here are muscles. Here are muscles at work. Go! Whether you are working these muscles or whether you're simply at rest, your muscles are always contracting.
Here we have a whole muscle. The muscle is made up of many fascicles, which are bundles of myofibers. Within the muscle fiber, there is mitochondria and a nucleus. Covering the muscle fiber is the sarcolemma, and underneath the sarcolemma is the sarcoplasmic reticulum. The muscle fiber is made up of many myofibrils, as you can see here. And the myofibrils are made up of myofilaments.
An action potential travels down the axon, arriving at the synaptic knob. As it passes by the calcium channels, they open, allowing calcium to enter the cell. The increase in calcium causes synaptic vesicles that are filled with acetylcholine to fuse at the membrane and release the ACH by exocytosis into the synaptic cleft. The ACH flows into the synaptic cleft and is picked up by the receptors on the motor end plate of the skeletal muscles. This causes the sodium-potassium channels to open, allowing sodium ions to enter the muscle fiber. The highly positive sodium ions cause a big depolarization, initiating an action potential. While this is occurring, acetylcholinesterase flows into the synaptic cleft and breaks down ACH into acetic acid and choline. Now sodium is blocked and the signal is stopped. The action potential travels down the sarcolemma into the T-tubules and stimulates the release of calcium from the terminal cisterna of the sarcoplasmic reticulum, where it has been stored by the protein calsequestrin, into the sarcoplasm of the muscle cell. Calcium floods over the thin filaments and binds to troponin, pulling tropomyosin off the active site on the actin. High-energy myosin heads leap to bind on the exposed active sites on the thin filaments, forming a cross bridge. The myosin head pivots to the low-energy state, releasing ADP and moving the thin filaments over the thick filaments. This is known as the power stroke. ATP binds to the myosin head, causing the head to break free from the active site on the actin. The myosin head becomes energized as ATP is converted to ADP. Calcium is pumped back into the sarcoplasmic reticulum and attached to calsequestrin, allowing tropomyosin to once again cover the active site, resulting in the relaxation of the muscle. Now we take a closer look at a sarcomere. A sarcomere extends from one Z disc to another Z disc. The thick and thin filaments overlap in a precise pattern depending on whether the muscle is contracted. It is this pattern that causes the striations in skeletal muscle. The middle part is the A band. It extends the entire length of the thick filaments, making it darker. The I band is lighter as it contains no thick filaments. A narrow H zone is in the center of each A band and contains only thick filaments. The M line in the middle of the sarcomere is formed by proteins that hold the thick filaments together.